Hello guys, welcome to episode 1 of the Python Crash Course series from Let's Pythonize. Today we'll discuss about variables and a small introduction to data types in Python. I am purposefully skipping the Python language installation part because there are many videos available on YouTube for the same, yet I have put a link in the description which will help you out with the installation. And a small tip, please don't type along with me in this crash course tutorial. Watch the video fully once, understand the concepts explained, and then try out the programs in this tutorial. Believe me, it truly helps. With that said, let's get started. I'm just going with the default IDE which comes along Python installation. If you are comfortable with other IDEs, please go ahead. But I personally don't recommend going for PyCharm. It's too heavy and too complex for a simple language like Python. Since the Python language is completely installed in my system, I am going to access the Python shell from my command line. If you have it installed, if you have the Python properly installed in your system, you can access it through the Python IDE software which you have installed. You can just open the IDE and you'll have the shell popped right away. I'm going to use it directly from the command line. So here we start. Variables are super easy to define in Python. Now let's create a variable named hello with the value 5. All you have to do is type hello equals 5. So how does Python know the type of the data stored in the variable? Over here, Python automatically recognizes that the value stored in the variable belongs to the integer data type. This function named type says the data type of a variable in Python. Here it reported that the variable named hello has an integer value. For decimal values, all you have to do is type hello equals 5.0 and type of hello. So what happened over here is, you might question that initially the variable hello had an integer value. Now it's having a float value. Wouldn't this conflict the memory? Yes, it will conflict. But when Python detects such conflicts, what it does is it automatically deletes the old variable instance from the memory and declares it again from the scratch. Therefore, it doesn't cause any issue. This feature was not present in Python initially, but for the easiness of the mathematical researchers, they decided to implement this feature. There is no way available in Python to declare a variable's data type. Python will do all those less important jobs for you. Now, we'll have a small intro to data types in Python. The data types we are going to cover are integer, float, string, list, and tuple. Let's start with the integer data type. Unlike C++ or other compiler-based languages, there is no limit for the integer size in Python. According to the requirement, Python automatically scales the memory allocation, which means you can perform how much ever big calculations you want in Python as long as your RAM supports it. RAM is the ultimate limit in Python for integers. You can declare integers simply like this. Yeah, that's it. An integer variable is declared. Now let's go to fractions in Python. Two data types are used to handle fractions in Python. They are decimal and float. Float data type is the simplest way to store fractions in Python. The number of digits after the decimal point is based on your computer's bit capacity. In most cases, this data type is more than enough. You can declare float like this. Well, you might have a doubt now. Both the numbers 1 and 3 over here are integers. Then how is the result a float? Well, for the simplicity of mathematicians, Python developers have decided to make float as the default output for integer division too. But if you want the integer part alone out of the division, then you have to go for /1 /3. Yeah, you saw that, right? It just gave the integer output alone, whereas over here it gave the whole fraction. In float, the number of digits after the decimal point is confined to around 15 digits. You can see over here, after this we don't have any more digits. But if you want to have more accuracy, that is, if you want to have more number of digits after the decimal point, then you have to go for the decimal data type. For that, you need to import the decimal library. I'll explain about library imports in a later video. For now, don't worry. From decimal, import everything. Now, I type decimal of 1 divided by decimal of 3. You can see over here that the number of digits returned by the decimal data type is high compared to the float data type. We can increase this digits count in decimal data type by the following statement. This will increase the number of digits after the decimal point to 100 in the decimal data type. I'm retyping the same statement again. You can see over here that 100 decimal places have been calculated after the decimal point. So in most of the cases this won't be required, but still if you want more accuracy you can go for the decimal data type. Again, over here your computer's RAM is the limit for the number of digits offered by the decimal data type. Now we'll go for strings in Python or texts in Python. We store text with the string data type. We declare strings by x equals, let's Pythonize, or x equals there is no char or character data type in Python. All are just strings. That explains why both double quotes and single quotes is accepted for strings in Python. To store multi-line strings, you should use triple quotes. X equals triple quotes. Let me put it in a new line. X equals triple quotes. Some random stuff. Yeah, you can see over here \n is the escape character for enter. So if I print x, you should see the text properly. Yeah, you can see the text over here properly, right? So multi-line strings in Python is created with the help of triple quotes. Now we'll go for arrays in Python. If you are from C++ or Java background, the upcoming array explanation for Python might seem a bit weird, but keep up with me. The data types in Python which offer array functionality are list and tuple. You declare a list by the following statement. X equals 1, 2, 3. Yeah, list. And for tuples instead of a square bracket, you go for a curved bracket. Yeah, over here you have got that the variable x is having a tuple data type. For a tuple with one or no elements, you need to put a comma after the element to avoid Python thinking it to be a normal group parenthesis. That is, x equals, if I type x equals curved brackets 1 close, and when I type of x, Python thinks that this is an integer because in most cases the parentheses are just for evaluating the stuff which is present inside the parenthesis. So to make Python understand that this is not an equation parenthesis and instead this is a tuple parenthesis, you need to put x equals 1, comma, and close parenthesis. Now I type of x. Yeah, that works. Even for declaring empty tuples, you need to follow a similar procedure. X equals sorry, I'm extremely sorry. Empty tuples are declared this way. Yeah. So the only difference between a list and a tuple is that once you declare a list, you can modify the elements present inside the list. But once you declare a tuple, you cannot modify the elements inside a tuple. I'll demonstrate it. X equals 1, 2, 3 and y equals 1, 2, 3. So x is a tuple, x is a list over here and y is a tuple. I am changing the value of the second element in x to 4. Yeah, it changed. Now when I try to change the second element in the tuple, it doesn't work. Yeah, tuple object doesn't support item assignment. It says that since you have already declared tuple, you should not override it again. Yeah, so that's the only difference between tuple and list in Python. This small difference makes tuples far more faster than lists in Python. There is one thing which you guys don't know till now. Both list and tuple can have any elements present inside it. So over here the first element is an integer, second element is a float, third element is a string, and Python will accept that. Yeah. This is the same case for tuples too. That's why programmers say Java, C++ arrays are perfect, whereas Python's arrays are shit. This might actually feel comfortable when you are a beginner, but when you start to program more in Python, this feature will actually be a pain. So with that, we complete today's episode. We'll discuss more deeper on the Python data types in the next episode. To stay tuned, subscribe and press the bell icon. Support me by sharing this crash course with your colleagues and friends. Hope this episode Pythonized you enough for the day. Thank you.